Hi everyone, my name is Vishal Bakshi and I'm an organizer with PyData PDX. In this video, I'm going to walk through the Pandas 102 Jupyter Notebook. Please follow us on Twitter at PyData PDX and DM us to join our Slack. You can find all Lunch and Learn materials in the GitHub repo linked in the video description below. The agenda for this mini lesson is as follows. I'll do a quick recap of Pandas 101, overview the topics for Pandas 102, and then do some coding. There won't be space for feedback here, but if you have joined our Slack, I'd love to hear any feedback you have there. Okay, so in Pandas 101, we covered what is Conda. It's a package manager for Python, how to install it, which is through the Anaconda distribution, how to create environments using the Conda command line, and how to launch and use Jupyter Lab. We also covered some fundamentals of pandas and NumPy, including data frames, series, ND arrays, and broadcast. In this video, you'll learn how to set data frame indexes, identify and handle missing data, update data frame values, and reshape a data frame. As always, I'll import pandas as PD and NumPy as NP. I've created a sample dataset which can be found along with all Lunch and Learn materials in the GitHub repo linked below. I'll read it into a data frame using the read CSV pandas method. Read CSV takes a file path along with other optional parameters to specify how to parse the file. The default separator is a comma. The header of the file, by default, is inferred, and if no column names are passed, read CSV will assume the header is in the 0th row. Once loaded in, I can view the head of the data frame. The head method by default will show 5 rows. You can pass an integer as the first argument. Here, I pass 20, but only see 14 rows since that's the full data set. The rows and columns of a data frame have an index. These are the labels that you see printed here. The row index is accessed using the index attribute. Here, our row index is a range of integers from 0 to 13. The column index is accessed using the columns attribute. Here, the column index is a set of unique strings. Indexes allow me to access the values in the data frame. The LOC method received the row index and column index. Here, the value in the 0th row under the product column is the string laptop, which we can see above in the data frame. In a broader context of a Python script, you may need to change the index to more easily access values in the data frame. Suppose I had a list of product IDs for which I want to get data from the data frame. I can set the index as ID to do this easily. The setIndex method will return a new data frame if the inPlace parameter is given false as its argument. If given true, it returns a none value, which is why here I have named the variable the underscore character as a placeholder for that none value. The ID column is now in bold. The index method now returns an integer index with the list of unique IDs. I can now pass the IDs, in this case, a list of IDs, to the LOC method and get back their data. Suppose that in a broader context of some script, I need to access rows based on ID, category, or condition. To accommodate this, I can set a hierarchical or multi-index. I'll use the reset index to go back to the original range index, and then set the index to a list of column names, ID, category, and condition. The indexed attribute shows that I now have a multi-index where each row has assigned to it a 3-tuple in the order of ID, category, and condition. I can access the first level of the index using LOC just like before. If I want to access deeper levels of the index, I have to pass a tuple or a list of tuples. When you receive this particular performance warning, you want to sort your data frame first by index, and then use a multi-level index tuple. If I pass a key in the second level of my index to the LOC method, I'll get a key error because electronics is not a key of the ID index. I can swap levels of index using the swap level method, which takes two strings and swaps their index position. Here, I'll swap the position of category and ID. So category is now first. Now I can access directly the electronics key and view the associated rows of data. A more flexible way to access all levels is to use the XS method, which creates cross-sections of the data frame. I can get a data frame of all rows where the category is electronics. The default level of the cross-section method is level 0. To access my level 1 row index, the ID, I pass an ID key and an argument of 1 to the level parameter. Finally, to access my level 2 row index, condition, I pass a condition key, new, and an argument of 2 to the level parameter. Since what's returned is a data frame, I can perform data frame calculations. Here, I calculate the number of total April sales of new items. Here, I calculate the revenue, which is product of price and April sales for all new items. Next, we'll look at ways we can identify and handle missing values in a data frame. The data set I will use comes from the London Air Quality Network. This data frame shows the site, species of pollutant, reading date time, the numeric value, associated units, and flag for whether the record is ratified or provisional. There are 46,026 readings in this dataset from one site in London, identified as BG1, and measure levels for 6 species of pollutants: barometric pressure, nitric oxide, nitrogen dioxide, oxides of nitrogen, rainfall, and relative humidity. These are 6 species, the maximum allowed, that I selected when downloading this dataset. And Not all are pollutants, as rainfall, relative humidity, and barometric pressure are just properties of air and the environment conditions. I can identify missing values by using the isNull pandas method. I pass it my data frame and take the sum along axis equals 0, which is the default for this method. This will return a series showing the count of null values in each data frame column. There are 8,788 missing values. I can pass a series to the isNull method as well and calculate the percentage of data that is null. I can remove all rows with a null value in the values column using the data frame drop NA method. I pass the string wrapped in a list for the column within which I want it to search for nulls. This method, by default, returns a new data frame, the length of which is 37,238 because the 8,000 plus rows where the value column was null were removed. Instead of removing those rows, I can replace them with a different value by using the fillNA method. Here, I replace missing values with zeros. Again, a new object is returned, in this case a series, so I can call the head method immediately. Sometimes you may want to fill missing values with existing non-null values in the data frame. To fill forward, meaning missing values are filled with existing non-null values before it, pass the string ffill to the method parameter. The values at the end are filled with the last non-null value of 29. You can also backfill, meaning missing values are filled with existing non-null values after it. Pass the string bfill to the method parameter. The values at the beginning are filled with the first non-null value of 996. Any numeric value can be passed to the fillNA method. Here, the mean of the value column will replace all null values. Again, none of these changes are taking place in the original data frame. A new object is being returned. Next, I'm going to run through some pandas methods which will help me update data frame values. Take a look at a value in the reading date time column. It's a string that shows 0 padded 2-digit day and month and 4-digit year, followed by a space, and then 0 padded 2-digit hour and minutes, separated by a colon. Instead of a string, I want it to be a timestamp. Because the data comes from the UK, the date format is day, month, year. So this is actually January 4th, 2000. However, the toDateTime pandas method assumes a month, date, year format for the string argument. I have to specify the format parameter with a string that specifies the date, month, year, hour, and minute formatting. The timestamp now correctly shows January 4th. I'll update the entire column, reading date time, by passing that column and the format string to the pandas toDateTime method. I'll check the head of the data frame and see that the update has been made successfully, and the reading date time column is a timestamp. The last section of this Lunch and Learn is on how to reshape our data frame to better fit the data we are exploring. To illustrate why our current data frame is unwieldy in its structure, I'll use a slice object constructed by start stop step notation inside of the brackets. Here, I'm starting at the beginning of the data frame, stopping at the end, and taking 8,000 row steps, meaning every 8,000th row is displayed. The data is in long format, which in this case means each daily reading of each metric has its own row. Instead, I want to view this data in wide format, meaning each daily reading of all metrics are in one row. To do this, I'm going to use the pivot data frame method, which takes the new index as its first argument, the new columns as its second argument, and the values under those columns as its third argument. I want to index the rows using reading date time. I want to see each species in its own column and the measurement values in each of those columns. Notice that here I have null values and non-null values in the same row because some species were recorded on a date, such as relative humidity, and some were not. Handling null values would require specific knowledge about how best to interpolate these measurements between dates. I can really see the utility of this wide format when I call the describe data frame method. It returns for each column the count of values, mean, standard deviation, minimum, maximum, and the 25th, 50th, and 75th percentile. Lastly, make sure to look through the references I've listed, as there's much more information that you can use to learn about pandas. Thanks for watching.